Okay, this is going on page 38 when we are done. Yesterday, we talked about what inverses were. We found the inverses. Today, we're still going to have to find some, but then we're going to verify that what we have are inverses. Let's talk about how we know that they are inverses. And so the first thing we're doing is going to verify inverses graphically. Okay, so two functions are inverses if they are reflections of each other in the line y equals x. Okay. So they are inverses if they are reflections of each other in the line y equals x. So then our first set of instructions says define the inverse of each function and verify graphically, which means you have to graph the original one and the new one and the line that they're being reflected in. So let's start by graphing this function here. It's just a line. What's my y-intercept? -6. So I'm going to go to -6, make a point. What's my slope? 3 over 1. So go up 3 over 1. All right, so then you use a straight edge, like the ID that's should be around your neck, and you can draw in a decent-looking line. All right, we also need to draw in the line y equals x, but I'm not going to make mine dotted because it's harder for me to do that up here, but if you want to make it dotted or lighter so it doesn't look like one of your lines. So graphing the line y equals x should be super easy. What's the y-intercept? 0. What's the slope? 1. Yep, so you just, whoop, y equals x. It's your parent function. Okay, so I've graphed the original one. Now I need to find the inverse and then graph the inverse. So I'm going to change this to y. So this becomes x equals 3y minus 6. I'm going to add 6 to both sides. Then I'm going to divide each term by 3. So it'll give me 1/3 x plus 2 equals y. So that means that f inverse of x is equal to 1/3 x plus 2. So now I want to graph that one. What's the y-intercept? 2. What's the slope? 1/3. So from here, I'm going to go up 1 over 3, and look at the point I just plotted. It's where the other two lines intersect each other. That doesn't guarantee me that I have an inverse, but it's helpful. So then you can draw in this line, and you can see that what you have is reflections in the line y equals x. This y-intercept, which is at 0, 2, means I have a point over here that's at 2, 0. This y-intercept that was at 0, -6, means I have a point over here that's at -6, 0. Okay? Everybody good with that? Okay, so we checked it. Yep, we verified it. We found it. We graphed them. Everything's good. All right, so let's look at number 2. Got to start off by graphing this. This is a cubic. Right, what's the only transformation that's happening here? Up 4. So my first anchor point is 0, 0. Then I go up 4. Then I have one at 1, 1. Go to 1, 1. Go up 4. Go to -1, -1. Go up 4. 2, 8. Puts me way off the graph after I go up 4, so I don't need to do that. -2, -8, and go up 4. Graphing's not going away. You should be able to do this quickly now because we've already reviewed it and done it. However, I have a feeling some of you still don't know how to do this, which is not a good thing. All right, so then I sketch this in, or draw it in. There's my cubic. Then I'm going to get my line y equals x in here. And then I don't graph my inverse right now, because yes, I know to find the inverse, I just switch x and y. But what I'm trying to figure out is, am I finding it correctly algebraically? So I need to find this function, or the inverse function, then graph it, and then see if they are inverses. So I'm going to change this to y. So this becomes x equals y cubed plus 4. So I subtract 4. And then how do I undo a cube? Cube root. So I'm going to take the cube root of both sides. Does it need a plus or minus? No. So that means my inverse function is cube root of x minus 4, just like that. Okay, and then graph this. Cube root looks like this. What's the only transformation I have here? Right 4. So I start at 0, 0, my first anchor point. You go to the right 4. Go to 1, 1. Go to the right 4. Negative 1, negative 1. Right 4. 8, 2 will put me way off the graph once I graph that. So I'm going to go to negative 8, negative 2. And then go to the right 4. And then when you sketch that in, the two functions and the line y equals x should all intersect at the same point. And then, again, you can see that you have this point here. This is at negative 4 and negative 2. So this one is at negative 2, negative 4. This point is at 0, 4. This point's at 4, 0. All we did was switch x and y. So we have verified, yep, they're inverses. Okay. What questions you got? Okay, so that is verifying it graphically. Now we're going to verify the inverses algebraically. So in order to verify them graphically, you have to be able to graph. To verify them algebraically, you have to be able to do algebra. And this is what this says. Two functions f and g are inverses if f of g of x equals x and g of f of x equals x. So we have to be able to compose functions like what your quiz was just over. Sometimes we have to find the function first ourselves. Sometimes they give it to us. This time we were given both of them, and we're supposed to just verify algebraically. That means that your work is your answer. You can't just look at it and say, well, it has to be because of whatever. No, you show algebra, show that that's what's actually happening. You have to show work and show that that's what you get in the end. So we have to do f of g of x, f of g of x. So that means I'm going to take g of x and put it in f of x. So that means I get 2x plus 7 minus 7 over 2. All right, so in the numerator, what is 2x plus 7 minus 7? 2x. So I get 2x over 2, which reduces to x, which is good news. But I'm not finished because that's just f of g of x. I also have to do g of f of x. So now I take f of x and I put it into g. So I get 2 times x minus 7 over 2 plus 7. What happens with the 2's? They cancel out. So that gives me x minus 7 plus 7, which is x. So g of f of x and f of g of x both equal x. So I've verified that they are inverses. What questions you got? You good? You need to go to the clinic? Nope. All right, let's sit up. We're going to skip number 4. We're going to go to number 5. Okay, this is just kind of putting it all together. It says, find the inverse of each function. That's one thing. State any restrictions on the domain. Then I have to verify graphically and algebraically. Okay, so don't confuse finding the inverse with verifying algebraically, which is what I see sometimes. You have to find it. Then we're going to verify it graphically and verify it algebraically. And we'll also have to state any restrictions on the domain. Okay, so this is a quadratic. This is what the parent function looks like. This, after the transformations, left 4 and down 2, is kind of what it would look like. Is this a one-to-one function? No, it is not. But it says this is, I'm only using it if x is greater than or equal to -4. So that means I'm only getting this part here. Is that pink part I just drew in a one-to-one function? Yes. So then we can move forward, right? And before I move forward, because I'm clearly going to have some restrictions in the end, this is my domain restriction of the original one. I need my range restrictions because that's going to become my domain. So what's the range of this pink part? -2 to infinity. Good. And I know that because I went to left 4 and down 2, right? All right, so that's the range of this one. So now I'm going to change this to y, and I will have x equals y plus 4 squared minus 2. All right, so I'm going to start by adding 2 to both sides, so I get x plus 2 equals y plus 4 squared. What do I do next? Square root. So this will give me plus or minus the square root of x plus 2 equals y plus 4. And then I subtract 4, so I get plus or minus square root of x plus 2 minus 4 equals y. Can I do 2 minus 4 and make that -2? No, they live in 2 different worlds. Totally not okay. So let's think about what this gives us, right? This is a square root function, and I would move to the left 2 and down 4. So it's going to look something like this, right? If I do plus or minus, this gives me my positive y values. This would give me the negative y values. Do I, well, I mean, they're all, there's going to be a lot of negative y values. But I mean, this is the plus the square root. This is the minus the square root. Do I actually want both pieces of that? Right, I just want the one that's above -2, which means I only want the positive one. I don't, even though we find plus or minus, we're only using half of it. Does that make sense? So that means in the end, my f inverse of x is just going to be the positive part of the square root of x plus 2 minus 4. Okay, so then my range restriction becomes my domain restriction over here, and that goes from -2 to infinity. Everybody okay with that? So that was step 1. We found it, and we stated the restrictions on the domain. Now we have to verify graphically, and then also verify algebraically. So graphically, we're going to graph this first one. So let's see. It's a quadratic, but we're going to the left 4 and down 2, but I only want the right half, right? So I start at 0, 0. I go to the left 4 and down 2. Then I go to 1, 1, left 4, down 2. Do I want to use -1, 1? No, because I only want the right half, right? So then I go to 2, 4, left 4, down 2. So that's the right-hand side of that quadratic that I'm using from the beginning. Then I need my line y equals x.
Teachers and students, please pardon this interruption. Teachers, at this time, please send your enrollment reconciliation down to the dining hall, please make sure that the pages are signed, each page, total per grade, and then once you have done that, you can send those down to the dining hall. Once again, please make sure that you have signed and total for each grade on each page before you send it down. Thank you.
Daisy, who do you think this is? Just take it to the dining hall. Thank you. All right. So now I'm going to have to graph the other one, which is the inverse that we found. It's a square root function. I go to left 2 and down 4. So I start at 0, 0, left 2, down 4. My next anchor point is at 1, 1, left 2, down 4. My next anchor point is at 4, 2, left 2, down 4. Whew, missed that one. Something like that. Then I have verified graphically, they are inverses. What questions you got? We good? All right, so now I have to do it algebraically, which is different. Did this require algebra? Yes, it did, but this was not verifying algebraically. This was finding algebraically. So to verify it, I have to do f of g of x, but in this case, I called them f and f inverse. So I need f of f inverse of x. So I take the inverse that I found, I compose it with f. So this is going to give me, when I substitute that in, square root of x plus 2.
One other quick reminder, please. Take attendance and
minus 4.
That was a 9:30 attendance, so thank you.
Plus 4 minus 2. Squared minus 2. Okay, everybody see how I substituted those in? Because you can't see my original up there, but you can see your own. All right, so this minus 4 plus 4 zeroes out. So I'm left with the square root of x plus 2 squared minus 2. What's the square root of x plus 2 squared? X plus 2. So I get x plus 2 minus 2, which is x. That's good news. Then I have to do the other. Remember, you can't just do one. You got to do them both. So now I'm going to do f inverse of the f of x. And that is equal to, inside the square root, where there's an x, I'm going to put x plus 4 squared minus 2, but then I still have a plus 2 in there, and then a minus 4 outside. Okay. Everybody understand where everything came from? All right, so these zero out, and I'm left with the square root of x plus 4 squared minus 4. What's x plus 4 squared? Square root of it. X plus 4. So I get x plus 4 minus 4. That's equal to x, and that's good news as well. What questions do you have? We're all good? All right, so I'm going to hand you the assignment. There's just 2 on here that you have to find the inverse, graph it, verify algebraically, just like we did, all of those parts there, and then just a few quick ones in Delta Math.